Okay, hello everybody. Today's project is a so-called capacitive impulse charger and car ignition coil driver. Okay, this is the same device which you see here. Okay, so you see a fan, and it cools this heatsink, and behind the heatsink there is a transistor down and a block capacitor, and here it's blue stuff is a big transformer. Okay, so this is the main transformer, and it produces 43 volt AC idle voltage from the 230 volt 50 hertz mains voltage. And there's also a filter capacitor which is 680 microfarads. This is a this is a polarized, okay, electrolytic capacitor. Okay, but this is under this chassis, okay, which is built. Everything is built on this rack. Okay, it's a disused rack, and so these are the components this device comprises. Now, in the back you can see the multimeter, and it shows 1023 millivolts. And if I turn this charger on, okay, so the voltage rises up pretty quickly. Okay, so it's a very quick charger, and it uses 50 hertz impulses from this 680 microfarad electrolytic capacitor, which is under this whole device. Okay, so it's rising up. It's not really warming up. Okay, if you let it run for 10 minutes, maybe it's just a little lukewarm. Okay, the battery is a little lukewarm. No big deal really. Okay, so this is how it works. Okay, and if I turn it off, so it goes back, but not as deep as it started. Okay, so it's 1200 millivolts now. Okay, and it's hovering around that. Okay, so yes, because the surface charge is usually higher, and then you need time to for the battery to settle. Okay, now another interesting function is this. Yeah, so the guy is cutting some masonry in the neighboring property. Anyways, and this is why I just paused it. So here is a car ignition coil. Okay, and on number 15, which is a Bosch marking, I connected the positive, and on number 1 I connected the negative, and with this piece of wire I just brought out the secondary. Okay, and here you see pretty beefy sparks, and it's quite noisy. I think it's also audible. All right, okay, so it really drives this car ignition coil. Okay, for any project it's very useful and very easy to build. Okay, yeah, okay, let's reconnect the, sorry about the background music, I hope it's not copyright there. Okay, yeah, okay, yeah, here is the charger back. Okay, so all right, so this is the charger running. Okay, now here is the circuit. Okay, so yeah, okay, I just killed that goofy music. Okay, now, okay. So, and here's the story. Okay, here you can see the mains, which is 230 volts. Okay, in my country, 50 hertz. And this is this blue transformer, okay, and it produces 43 volt AC, okay, this is the idle power, but maybe 30 volts, but if you put the filter capacitor, which is a 680 microfarad electrolytic capacitor, then it raises up to 43 volts DC, okay, this is the idle voltage, okay, and on the positive, the red cable, so the positive goes to number 15, okay, and this is the primary, and it goes back to number 1 and to the collector, down the emitter, and back to negative. Okay, so I think it's clear. Okay, so the positive goes like down 15, back to 1 on the collector, on the emitter, and back to negative. Okay, so much. But the driving circuit is a little bit more interesting, and it says it's a snap. Okay, because on either, okay, yeah, this is a very hard-working man in the neighborhood. Is working his butt off even on Sunday afternoon, or yeah, sorry, it's in the morning. Right, good. Now, okay, as you see, now the voltage is 1700 millivolts, around that. Okay, 17, 18. Now, yeah, okay, so back to the schematics, and so, okay, maybe I should zoom in a little. Okay, yeah. So this is you can connect this 5 microfarad foil capacitor or block capacitor on either end of the secondary AC. Okay, so either end. This AC through this capacitor will control the base of the transistor. Now the transistor is a BD245C transistor. Okay, so you have this base, collector, emitter. Okay, and the tab is connected to the collector. Okay, as customary. And yeah, this is it. And so the charger is very simple. You just connect it to the battery. Okay, so this is everything is the same, but in place of the ignition coil, you connect the battery. Okay, so through to the pulse, through to the poles, like negative to negative, positive to positive, and you let it run. And as you see, it runs quite nicely. It's a very little lukewarm. Yeah, it lukewarm a little bit. Yeah, after a few minutes, it gets a little warm, but not very dangerous. Okay. And if you turn it off, yeah, then it goes back as usual. Okay, so yeah, sure, it was just a surface charge. But anyways, it varies from battery to battery. Okay, because maybe you can put another battery in. Let's check it with another one. Active energy. Okay, let's see how much charge it has on. Okay, 12 something. Good. Yes, if you are recharging used batteries, you have to experiment, because some batteries take new charges, others just won't, and you don't have to worry about them. You just scrap them, or maybe you can build another project and try some other ways. There are other ways, for example, inductors, not just capacitors. But this is a capacitor approach. Okay. Sometimes inductors are better because they are good for desulfation and stuff. Anyhow, so yeah, this is the story. Okay, let's wait until it reaches 1500. Now it's 1500. Okay, and if I turn it off, okay, so it goes back. Yeah, sure. Yes. Okay, but so you see my point. Okay, so that's the point. Okay, so it's very easy to build. Good luck.